In this video, I am talking about Boyles and Charles gas laws. First, we'll focus on Boyles' law, then we'll go to Charles' law. Boyles' law is a relationship between pressure and volume. Reminder, pressure for gases is number of collisions with container. Volume is space. So pressure and volume are changing, but constant will be our temperature. We will not change temperature in a Boyles law experiment. So looking at this visual, my first container, I have a pressure of 1 atm, and my volume is 1 liter. My volume goes down to 0.5 liters, but my pressure increases to 2 atm. So my pressure is increasing and my volume is decreasing. That means at constant temperature, as pressure increases, increased pressure, we decrease volume. Direct or indirect? A direct relationship occurs when two variables are moving in the same direction. Indirect means you're moving in opposite directions. So here we see that we are increasing and decreasing. Is this a direct or an indirect relationship? Indirect. When a relationship is indirect, the graph is going to show that as it's going down. So I'm going to have a decreasing graph. And it's going to have pressure on the x-axis, because remember, we changed pressure, so we changed x-axis. The volume changed on the y-axis due to pressure. The equation for this will be P1V1 equals P2V2. Going through the example, I look for my pressure and volume, and I annotate. So volume, pressure, pressure. So a sample of gas in a syringe has a volume 9.66 milliliters, pressure 64.4 kPa, which is kilopascal. Plunger is depressed, so I'm pushing down on this container. My original container has 9.66 ml, and a pressure, so push on it, of 64.4 kPa. And then it's now has a pressure of 94.6 kPa, so I increased pressure. Remember, if we increase pressure, volume should have decreased. So we're trying to figure out what is our volume. So I plug this into my formula. 9.66 times 64.4 equals 94.6 times V. I'll divide both sides by 94.6. So when we type that into our calculator, top always multiplies, so 9.66 times 64.4. So I have 9.66 times 64.4. Then I divide by 94.6. My volume is now 6.58 milliliters. I'm rounding to the second decimal place. 1, because we round to the second decimal place in my class. 2, this is actually following 3 sig figs. So 1, 2, 3 sig figs, 1, 2, 3, 1, 2, 3. So my answer is in 1, 2, 3 sig figs. Does this make sense? Well, we wanted a smaller volume. Is 6.58 smaller? Yes, so that means I solved this correctly. Next will be Charles' law. We're asking the same questions. So I have a relationship between volume and temperature now. Remember, volume is space. Temperature is the movement of molecules. At constant is pressure now. So we see that pressure stays constant, so it's not important. But my size does change because volume goes from 0.5 to 1.0, so volume has increased. Temperature, on the other hand, went from 200 to 400, so it also increased. So at constant pressure, as temperature increases, so increase of temperature, volume also increases. So is that a direct or is that an indirect relationship? It's direct because as one increased, the other also increased, so it's the same direction. If it's direct, that also means that if volume decreases, temperature will also decrease. Graph. Because it's direct, I'm putting temperature on the bottom because we changed temperature. Volume on the y because it changed due to a change of temperature. We see that it's a direct relationship, so if I increase temperature, volume also increases. So this is my original temperature and volume. I increase temperature, it increases volume. What if I had started here and I decreased temperature? Well, I would have decreased volume. So I end up with this line. The equation is V1 over T1 equals V2 over T2. That means we'll use cross multiplication most of the time in order to solve these equations. So a volume of a sample of gas at 0 degrees Celsius is 200 liters. If the volume is decreased to 100 liters at constant pressure, what will be the new temperature of the gas? So T2, so it's my second temperature. It's my original temperature, my original volume, and my second volume. So I was 200 liters. Then I was 100 liters. I want to figure out the change of temperature. I know temperature was 100 degrees Celsius, but we can't use 100 degrees Celsius. Instead, we have to use Kelvin, so 0 plus 273. This is 273 Kelvin. So we're trying to find T2. Do you think T2 will have increased or will it have decreased? Remember, volume decreased. If something is a direct relationship, that means it's moving in the same direction. So, temperature should have decreased. When I plug into V1 over T1 equals V2 over T2, I'm going to plug in 200 over 273 equals 100 over T2. I'll cross multiply. So 200 times T2 equals 100 times 273. And I'll divide both sides by 200 in order to cancel out my 200 on my original side of the equation. So when I type this in, I will have 100 times 273 divided by 200. Enter 136.5 Kelvin is my final answer. So did my temperature decrease? I double checked. It was 273, now it's 136. It did decrease, so I solved this correctly.